Hi everyone, here we're going to look at finding an equation from its gradient function, and in this example we have a gradient function. Why do we know it's a gradient function? Well, it has that notation dy by dx at the front indicating that it is a derivative or a gradient function. We're told that the curve passes through this point and we're being asked to find the equation of that curve. So given the gradient function, the way to get the function of the curve is to anti-differentiate. And if we're sort of being kind of formal with our notation here, what we can do is kind of times both sides by dx. So we end up getting dy equals 3x squared minus 8x plus 1 dx. And the reason why it's useful to do that is because then we can write the integral symbol on both sides. And so it's like we're continuing that notion in algebra where we have to do the same thing to each side of an equals. So the integral of a dy is simply going to be y, and then the integral of this side is going to be, well, we'll just take it term by term. So raise the power by 1 and divide by the new power. Raise the power by 1, divide by the new power, and then we're going to have an x and a plus c. Now it's asking for the equation of the curve, so that means that they want us to evaluate what plus c is well, and that's where these points come in. So I've got an x value and a y value. So I'm going to put 3 in for my y value, and I'm going to put negative 2 in for my x value. So that's what I'm doing here. Plus negative 2 plus c. Okay, so we're going to have 3 equals negative 8 minus 16, so that's negative 24, minus 2, which is negative 26, and then we've got plus c. So my c value is going to be 29. So now we can substitute that back into our original equation instead of c, and so we can give our full equation of the curve as x cubed minus 4x squared plus x plus 29. And that is how you find a curve given its gradient function. And this is often one of the most common uses of anti-differentiation. So I'd like you guys to practice some of these on 22.04, please.